Today we are going to solve 2001 AP Calculus FRQ question number 4. So it says, let h be a function defined for all x is not equal to 0, such that h of 4 equals -3. And the derivative of h is given by h prime of x equals x squared minus 2 over x for all x cannot equal 0. Okay, so x can't equal 0. That's important. Find all values of x for which the graph of h has a horizontal tangent and determine whether h has a local max, a local min, or neither. Each of these values justify your answer. So we have h prime of x, that's the derivative, equals x squared minus 2 over x. And if we set this to 0, that's where you're going to have a horizontal tangent. So we get x squared minus 2 equals 0. X squared equals 2, x equals plus or minus root 2, and don't forget about the 0 here because that's going to be a critical point. So now we're going to make a number line. So here's negative root 2, here's 0, here's root 2. Now we're going to test to the left and to the right of this. So what's a number bigger than negative root 2? Negative 10. So you're going to get positive over negative, it's negative. Now pick a number between negative root 2 and 0, negative 1. So you're going to get negative over negative. So that's positive. So that's a min right there. That's a min because it changed directions from negative to positive. Okay, now we need to pick a number bigger than 0 and between root 2. So 1. You're now going to get negative over positive, so it's negative. And now pick a number bigger than root 2, which is 10. So you're going to get positive over positive, so that's positive. So this is also a min, and it didn't want a max. So these are all my horizontal tangents, negative root 2, 0, and root 2, but it says you can't include 0. So min at x equals negative root 2 and root 2 because h prime of x equals 0 and the sign changed from negative to positive. Sign changed from negative to positive. Okay, part B. Okay, part B says, on what intervals, if any, is the graph of h concave up? Justify your answer. So if we want to find concavity, we need to take the derivative of this. So the second derivative, so h double prime of x. Derivative of the top is 2x times the bottom minus derivative of the bottom times the top all over bottom squared. So now you're going to get, let me zoom out a little bit. Why is it not zooming out? Okay, I could do this. Okay, so now we're going to get 2x squared minus x squared plus 2 over x squared equals 0. So now we're going to get x squared plus 2 equals 0. So now we're going to get x squared equals negative root 2 or equals negative 2, which is not going to be anywhere. So now we have to determine if this is concave up or concave down. Why can't I move this? Give me 1 second. Okay, so anyway, x squared plus 2 equals 0. It will never equal 0. So now test points. If you pick numbers and you plug it into here, if you plug in negative 10, you're going to get something positive plus 2. It's always positive. If you plug in a number bigger than 0 or whatever, it's always positive. So it's always concave up. Concave up everywhere except x cannot equal 0. Okay, so anyway, part C says write an equation for the line tangent to the graph of h at x equals 4. So we have the point because it gave it to us before, 4 comma 3. If you want line tangent, you just need the slope. Luckily, we have the slope formula, which is the original derivative. So now we're going to get 16 minus 2 over 4, which is going to equal, what's that, 14 over 4, which is 7/2. So now we're going to get y minus 3 equals 7/2 x minus 4. Okay, so part D, it says, does the line tangent to the graph of h at x equals 4 lie above or below h for x is greater than 4y? Well, it's going to lie below because this thing is concave up. The tangent line will always lie below because h double prime of x is greater than 0 everywhere, including x is bigger than 4. I hope this video helped, and I'll see you guys next time.